everyone. Great to see you. My name is Dom Divakaruni. I lead product for Azure OpenAI. And I'm joined by my esteemed colleague, Pablo Castro, who leads Azure Cognitive Search. And I'm super happy to be here with you all, here to talk about Azure OpenAI and the tools that we're building to help you develop applications with it, to develop copilots with it, and excited to share a bunch of new announcements, some of which you've heard during Scott's talk, and dive into it in some more details here. You've heard a lot about this, but again, sort of setting the stage, the field is as old as some of us here in the room, and it's really been accelerating since 2012. Started with the AlexNet paper and then the Transformers in 2017, but really it's picked up steam in the last couple of years, right? Like none of us have seen this pace of innovation, and it's really changing all our lives in such a meaningful way, very, very quickly. Seen in no other than ChatGPT in how quickly it really captured all of our attention. In no time in history has technology or really any innovation captured all our interests so quickly and has reached the adoption levels of ChatGPT as we've seen. So in really 2 months, it has scaled to 100 million users, and it just speaks to how useful and practical it is in all our daily lives, and it's intuitive, right? And so we at Azure AI are happy to build all these innovations into products to make them second nature for us to consume in our productivity suites, in search engines that we use, as well as low-code, no-code tools that we all use in Power BI and Power Apps. All that consume the powerful AI models in the customizable AI model layer, including Azure OpenAI, which is our service that brings together OpenAI's most recent innovation to life so you can build applications with it, because that's what's most important. And all of this runs on Azure Machine Learning, our massive scale AI platform that helps all these innovations come to life. And so we look at Azure OpenAI. What is it? It is our platform that helps us bring OpenAI's research to life. It rides on a foundation of enterprise security with all the highest security standards and what you expect from the cloud and what you can depend on, where your data is private and it remains in your tenant, and none of it is used to train or improve our systems or train machine learning models. And provides you with all of OpenAI's models as quickly as we possibly can, including the most recent GPT-4 model, that's really captured all the attention of the industry. It's lighting up all these unique use cases that haven't been possible before, right? Summarization, reasoning over data, writing tools, code generation, and now ushering in the era of copilots. And so GPT-4 is the latest to the state-of-the-art from OpenAI, and you've heard a lot about it. It achieves human-level perf on text generation. It lets you steer it with nuanced instructions. Actually, OpenAI will tell you that they've had this model in done training and still in development for about 6 months. And that time was carefully spent tuning the model to make it more steerable and useful when you instruct it to do something. And it really shows, right? I don't know if you all have had a chance to play with GPT-4, either in ChatGPT or the Azure OpenAI service, but what you're able to do with it is really remarkable. Just, there was a time in the past where prompt engineering really was considered an art, and it really took a lot of coaxing to get the model to do what you needed to do. Not anymore with GPT-4, right? Just with a few instructions, what you can create with it is freaking phenomenal. And so all of that is really being used by thousands of customers. I think Scott cited 4,500 customers that are using Azure OpenAI today, and really building with it. Coursera is a great example of a customer that is building AI-powered learning experience on our platform. to help learners with sort of an interactive learning experience that helps learning be a more personalized journey than one that is generic and crafted and that's out there, and we have to adapt to it. And so as we look at this, we see 3 use cases really emerging. One is where AI is embedded into products we use, like search, and makes things fundamentally better, right? Search synthesis as opposed to search results on a page that you have to discern what the right thing is for you. And really, like, pretty simple use cases, like generating blogs or helping us write emails. To the next level above that is what we've seen just over the past few months with ChatGPT, is where it's helping novices learn topics that they are not familiar with a simple Q&A-based style learning. And that really opens the doors for us to become more effective at everything we do by just simply asking the model to help be our co-pilot, to guide us along a task. And the last part where we're seeing these models really help and emerge is to help experts be more efficient at what they do, sort of offloading their tasks and sort of helping the knowledge worker be more effective at what they do. And so we're seeing that in no other place than Epic. Epic Healthcare plays a major role in the industry, in the healthcare industry. And we're helping them incorporate GPT-4 into electronic health records. They are helping medical professionals use their time more effectively. And another great example of helping the expert is DataRobot, right? DataRobot, our partner, who's incorporated Azure OpenAI to help their customer cohort, their customer base of data scientists and ML practitioners be more effective. Lots of, machine learning has been out there for a long time. Lots of customers use it in their mission-critical applications as part of their workflow and the tasks that they do. And so what this integration helps customers at DataRobot do is it helps them do their jobs more effectively. It provides data scientists with some analysis, which they can go fact check, and helps accelerate their journey, helps create more models and put AI into more places. And so with this, I'm happy to share a couple announcements. We talked about the models that are available on the platform. And so this conference at Build is all about us taking that a step forward, helping you build co-pilots along with these technologies. And so I'm happy to announce 4 different capabilities, and Pablo will talk about one more with Azure Cognitive Search. And it's the first to really help you extend the capability of the models, incorporate your own data, because that's really when it's useful, is when you're able to apply your data to it and garner insights from it and help leverage the model to power insights and power your applications. And then the last 2, which I'll go into, are innovations that really provide you more control over the way you integrate the service into your applications, and also a provision throughput, which is a capability for large-scale production applications. So let's dive into it. Sort of to go from a 10,000-foot level down much, much lower, let's talk about the API interface that sort of makes this possible today, right? It's called the Chat Completions API, which is kind of all-encompassing. In the past, you may have been familiar with the Completions API, and you use the Completions API to sort of ask the model, and it's a single question response kind of interface. This one not only does everything the previous API did, but it also enables chat, which enables these Copilot-like scenarios, where if you look at the code there, it allows for a couple different fields. One is the system field, which is really the system message, or as Kevin talked about, the meta prompt, which you can tailor to tell the model exactly how to behave, what to say, what not to say, what parameters to stay between, and really steer the model for your particular application, for your particular use case. And then you can stick a couple more examples, any number of examples into the prompt, as long as the prompt length goes. And under the role of user and assistant, you can provide the model with some examples to help steer it. And in fact, what we're finding internally is that this paradigm of using the system message and examples in user and assistant gets you really a long way than the traditional approaches with using fine-tuning, where you really have to go low level, you have to train these models with your data. And it's kind of a tough mental model and paradigm for us to break, where a lot of us in the machine learning field, fine-tuning is just a natural thing, right? You have a base model, you got to fine-tune it for your particular task. And what we're really seeing is that increasingly, with each generation of model, you're having to do that much less and less, where the system message combined with examples that you can put in the prompt really get you quite a distance. And so the challenge that, per all the keynotes and the talk so far, the challenge that we run into is, great, the model is fantastic, it has a base level of knowledge, probably trained in 2022 with GPT-4, but it doesn't have my context, right? And I want to put my context into the prompt length isn't long enough, what do I do? And I don't want to have to keep sending the model all these tokens for my entire document at once. So the conventional solution that we keep telling customers is build a vector database and go at runtime, go find the relevant snippets that pertain to your query, craft your prompt, and run it. Has worked for a lot of customers for quite a while now, but we felt that this was an opportunity to make it easier for customers. And so I'd like to introduce Azure OpenAI on your data. We've built a really easy way to make it easy for developers to ground Azure OpenAI on your data. So you can combine a model like ChatGPT, which is GPT 3.5 Turbo, or GPT-4 with your own data and build your assistant that reasons over your private data, right? And it does it securely within your Azure tenant, in your Azure resource. No data is shared with anybody. Your data is not used. Again, I'm trying to hammer this point home because it comes from a lot of customers, is your data is not used to improve our systems or train machine learning models. It's all in your own tenant. And so we have a number of data sources to start there in the top blue. We'll be expanding to a number of additional data sources in the weeks and months to come. And really, it is to extend the capability of these models for you to ground it on your own data. And so why don't I flip to a demo of what this looks like. You've seen some of this on stage, but I can go into it in a little bit more depth. And we all know how live demos go, so keeping my fingers crossed for the demo gods to shine, to smile on us. All right, here I am in the Azure OpenAI Studio. This is being called the Azure AI Studio as we bring together a lot of industry open source models for you to really take advantage of the most cutting edge in AI. And so I'm going to flip to the ChatGPT Playground. God, I hope this loads. It did. OK. So what I'm going to show you first is the base model without grounding with your data, right? So I'm going to type in something simple like does think of this as a chatbot facing your employees for them to learn about some specifics in your health insurance plan. And I'm going to look up on this. The model is either going to say, I don't know, or come up with an answer that's pretty generic. OK, the model, sure enough, said it doesn't have information about specific Premier health plans. And so now I want to ground this with my data. And we've introduced this new add your data field. By the way, I meant to say back on, before I get to add your data, on the system message, in case you're not familiar with it, this is where you can go, craft your specific instructions to the model to tailor it to what you want to do. So I'm going to go back to add your data. I'm going to add a data source, and here we have a number of options for you to use. Blob stores, you can upload files, whether that's PDFs or Word documents or what have you, and or you can use your vector, your search index, Azure Cognitive Search, which I'm going to use for this demo. And so I'm going to choose a service, a Cognitive Search service, and I acknowledge that I may incur charges for the use of this. Gosh, this is going exceedingly slow. OK, that doesn't seem to want to work. Let me try reloading the page. Pardon me, folks. We'll get there. OK, for instances like these, I do have a spare recording. So we'll have to go to that, and you'll have to pretend like I'm doing this live. And we'll just have to roll with it. And you can see I recorded this morning. I'm certainly not, it's great that AR, VR is not my day job. I clearly have this thing that it says it's recorded. OK, so I'm going to jump in here and fast forward. I go add your data. And at this point, I look through my data sources. I look at my Cognitive Search index and choose, and this is where I was before. I chose my search index. And now I want to map the columns in my index to citations that I want to see when it generates an answer. Perfect. I choose fields that match what I want, match my search index. And this is key, right? I want to be able to say limit responses to what's in the data content. Oftentimes, you build this thing, you don't want the model to stray off in some randomville and provide your employees with something it's not supposed to respond to. You can certainly do that in the system prompt. Right? You can craft it to say, don't do this. But you can also say limit responses to your data content. And that just a Thank you. Is it still? Top left? And the winning answer goes to Swap Displays. Got it. Awesome. It's teamwork, folks. Teamwork makes dream work. All right. We're here. And now I'm going to go ask it the same question. Are eye exams covered under the Primera plan? It says yes. Eye exams are indeed covered. And provides you a citation. Always check AI's work. And you're able to go see on the right-hand side what document did it pull up, did it do the right thing. OK, perfect. And now there's another neat feature that's baked into here, which is I can go publish this as a Azure App Services web app, which then lets you easily provide an interface that folks can interact with. So you can either test this out, or you can go take that web app and extend it to your own use case. You can add your own authentication on it and make this your own for your own companies. And so this is the view of that web app. Imagine that I published it. And you go ask. This is like a standard user interface, right? No one's actually going to go to the Azure OpenAI Studio. They're going to go to this sort of an interface that you build for your own company. So this is another way that we make it to make it really easy for you to go build an interface that you could present to your, build your own Copilot and present it out to your audience. OK. With that, I am going to flip back to could you flip back to the slides for me, please? OK, awesome. With that, I'm going to introduce you to Pablo, who will walk you through sort of under the covers of how you create your search index and what powers the experience that we just saw. Thank you, Pablo.
Thanks, Dom. Hi, everyone. Good morning. As you probably already heard this morning during keynotes and whatnot, integrating large language models with your own data is one of the key challenges that we all face when constructing new generative AI applications. The emerging pattern for this is what we call retrieval augmented generation. The idea of retrieval augmented generation, or RAG, is to separate the large language model from an externalized knowledge base, all coordinated with an orchestrator that mediates the interaction between these two components and the rest of the application experience. Now, there are different ways to kind of bundle these together. Like sometimes you'll build your own applications. Maybe you're building your own Copilot or your own custom experience where you control the application user interface. You build your own orchestrator, either with the technology Dom just showed, or maybe you're using LangChain or semantic kernel to orchestrate all of these things together. And in the end, at that point, you build the entire stack on your own, and maybe you use a large language model and a retriever. Or sometimes you'll build a plugin, which is a way to use extensibility in other systems like ChatGPT or GPT or any of the other surface areas as we discussed this morning that now support plugins. Now, a key element is that in all of these scenarios, what we have is an externalized knowledge base. This allows us to bring data that is not about the model. We use the model because of its capabilities to absorb information, reason about it, and give us answers. But we don't want its knowledge. We want the knowledge to be the one we bring in through the knowledge base. Now, if you think about the actual knowledge base, let's think about what is the problem statement we need to tackle. So what we want to do is we want to externalize knowledge into this retriever. And what the retriever needs to do is find the most relevant pieces of information across a very large set, given just an unstructured query. So the systems that do this have a name already, and they're called search engines. In the context of Azure, Azure Cognitive Search is the solution for retrieval that can power all of these applications. And it'll do all the it'll bring all the building blocks that you'll need, from data ingestion to scaling, to enterprise-grade security, to dealing with written languages and whatnot. Using cognitive search, you can now create a knowledge base there, and along with a large language model, create an integrated experience for customers. Now, traditional methods for search are very often very effective for this. So you'll use things like keyword search, symbolic manipulation of text for linguistics, and things like that. And that has proven effective in a number of ways. That said, another emerging trend these days is to also use representation-based retrieval, or vector or embeddings for retrieval, which are complementary to traditional methods in the sense that they can do semantic-based retrieval that's very useful in some cases. So let me very quickly first establish what do we mean by semantic similarity. Like, the idea is you can learn a model such that imagine you have a kind of high-dimensional vector space that you train such that things that mean similar things are close together in that vector space. There are many ways to do this. I'm happy to talk about the details later. But think about that as the outcome. Now, if you have a system like that, then you can encode maybe words or sentences or pictures or pieces of audio. And they are all, as long as they are all in this vector space, then you can define similarity as, hey, if I find vectors that are close together, then I found things that are similar. You can do this using the Azure OpenAI Embeddings API. There are many excellent open source embedding models, like SentenceBird or Clip, or you can build your own. Now, once you have an embedding, The problem of vector retrieval kind of split in two. First, you need to think about encoding or vectorizing your content while you're ingesting it. And then at query time, when you use it, you want to vectorize the query as well, because in the end, you're comparing vectors to vectors at that point. Once you have that done, the second part has to do with vector indexing. And by that, what I mean is you have a ton of content, and you've run this content through whatever preparation you need to, then through an encoder, and put it in a vector database. And then when a query comes in, you take the query vector, and you have to find the k closest neighbors to that vector real quick. So for large collections, doing this exhaustively, as in kind of comparing every vector, is completely impractical. So in general, what we do is approximate nearest neighbor search. And there are a number of techniques to do that. So in the context of Azure, I'm very excited to announce that Azure Cognitive Search now has native support for vector search. And we do this by introducing a new vector type that you can add to your indexes. And once you have that, you can use Azure Cognitive Search either as a pure vector search solution for the cases where you only want vectors, or as a hybrid retrieval solution, where in many cases for these retriever systems, you get the best quality of results by combining the best of traditional retrieval methods, or kind of keyword search-based retrieval, with vector-based retrieval, where what we can do is we can query both fronts, then fuse the results, and present you the best candidates. Additionally, we support combining this with our second step, our L2 re-ranking system that is powered by the same models that powers Bing, such that by just enabling this functionality, you can have us do hybrid retrieval from vectors and from keywords, feed that into a secondary re-ranker where we'll re-rank for the best results, and then return that to the caller. So all of that is just built for you, so you don't have to deal with the challenges of retrieval, and you can focus on the functionality of the application. And of course, we'll do this in the context of Azure with enterprise-grade security and scalability and so on. So let's actually see this in action. We can switch to the demo monitor. Excellent. So let me start here. So what we'll do first is we'll just go and look at exactly what the API looks like. No fancy applications up top or anything, not even the SDK. We'll just do REST calls to see what does it look like to create and use a vector index. So what I have here looks like a typical Azure Search step to create an index where you define some fields. In this case, I have a couple of, I have a searchable field, a filterable field. But I'm also introducing a vector field right here. And in this case, I'm saying the dimensions. I'm using 3, so we can actually read the stuff. Practical numbers for these are usually in the hundreds or maybe low thousands. And then I'm indicating a vector configuration, which here it says what kind of vector index I want to create. In this case, I'm using HNSW. It's one of the ways you can organize vector indexes. And I'm describing what is the metric, as in how do we measure how close vectors are. In this case, I'm saying cosine. We support a few other metrics like dot product or Euclidean distance. So let me run this request. And so now I have a vector index that also has I have a hybrid index. It has vector and text. So next up, what I want to do is index some data. Again, this looks like a pretty normal Azure Search indexing request. It has 3 documents, first, second, and third. The only difference is one of the fields is a vector. And usually this is like maybe 1,500 floats. In this case, I'm just having 3, so we can actually read through the stuff. I'm going to click send. And great, so now we have 3 documents indexed. So now let's run some vector queries. So the simplest query I can run is I can just say, hey, here's a vector, and give me the K10, the closest 10 ones, using as a reference this field number 1. I'm going to run this guy. And you can see I'm getting all 3, because in the end, they all match. The question is how far they are from the vector, and the score kind of indicates that. In fact, if I move this vector a little bit, I'm going to put it in this position and run this query again. You can see that the first one is almost there, because it's actually the same spot, kind of within precision. Now, this was pure vector search. A couple other interesting things you can do is, one is you can combine vectors with filters, maybe for security purposes or to kind of customize the experience. So I can, in this case, I'm going to say filters. And you can see this has category A, category B, and whatnot. So what I'll do here is I'll say category equals B, and run this query again. And now you can see I get the ranked results, but only the ones that fit the filter criteria before we evaluate the vector similarity. Lastly, I talked about hybrid search, very fancy sounding kind of mechanics, but the way to use it is pretty simple. You just say search, and you give us keywords. So in this case, I'm going to add second, as in for the second document, and I'm going to run this request. And you can see now, the second document kind of ranks higher because we're combining kind of the scores. We're fusing kind of the retrieval from the keywords and from the retrieval from the vectors, and then computing the kind of a fused set of scores for them. Well, just in this minute, what we did is we created a search index with a vector, indexed some vectors, and then searched. Let's see this real quick on a complete application. This random battery thing I have open. All right, there. So this is one of the example applications that we show, and actually this is in GitHub if anyone wants to try it. So let's say, typically this is the way it works is we have an Azure Search Index. You give us a question, look it in the index, and then feed it to the model to answer the question. Now, sometimes people can ask questions, and we always find, there is always someone that will ask a question like this. This is a healthcare kind of website or kind of for employees. So they'll say, instead of just saying hearing device, they'll say, some mechanical waves reaching the sides of my ear. Like the point is, the retriever has no hope because all these words don't quite mean anything from the retrieval standpoint if you're looking for words. So well, that's awesome. Let me do this. I promise this will work. Nothing like killing the thing and starting it over. There. One more second. So I'm going to retry now. Let's see if it's up. Oh, there. Now it's up. So the model has not much to work with because we didn't retrieve any document that is useful to it. So actually, I'm very glad that the model manages to say it doesn't know because we don't want this model to spin. There is an answer somewhere in this knowledge base. The problem is the question is too contrived. So let me fix this by using Azure Cognitive Search vectors. So what I have here is in my index, this is just the Azure portal, so we can take a look at what's under the covers. You can see that I already created my content. I also have actual embeddings. I'm using the Azure OpenAI Embeddings API for this. So now I'm going to go to my code real quick here. This is where the search happens. And I'm going to add vector support here. So what I'll do is I'll say query vector equals, and I need to embed the query as a vector. So I'll say OpenAI.embeddings. Create, and then the engine I want to use is, I have it in my configuration already. And then the input is Q, is the query that I'm getting from the user. Okay? So now, once I have a vector, what I want to do is, in my call to Azure Cognitive Search, I want to pass the vector as part of the query. So I'll say vector is, so I need 3 inputs. One is the actual value of the vector. In this case, is query vector, which is calculated. K is how many we want to retrieve. I already have a top argument for that. And then fields is which fields to look into, which the name of my field in this case is embedding. I actually need to dig into the response a little bit and get the actual part that I care about, which is the actual vector. So we'll go with that. Let's put a breakpoint here and see what happens. So now I'm going to ask the same question again. And if I look at here where I hit the breakpoint, what I have here is the vector representation of this question. And actually, this works much better when you actually restart your application if you change the code so that you actually pick up your changes. So let's try one more time. There. So now I have an actual vector representation. So this is what OpenAI computed as the encoded version of my question. So now I can send this to Azure Cognitive Search and then compute the results that then I'll send to the completions API to compute an answer. And so now that we have like actual data to work with, then the large language model can provide a reasonable answer to the question. And it actually understood that I'm talking about a hearing aid device instead of some kind of convoluted description of what it was. So if we can go back to the slides. So again, very excited to bring native vector search support as part of Azure Cognitive Search for all of you to create the next generation of large language models powered applications on your own data. This is in private preview today, and you can go to this link to sign up. And now, to talk more about how they've been innovating using Azure OpenAI and Azure Cognitive Search, I want to roll a video from one of our customers, Schroders, who've been kind of innovating and trying in the real world some of this technology. Let's roll the video, please.
Hi, I'm Jamie Omden. I'm the Group CTO at Schroders. Schroders is a global investment manager. We manage nearly $1 trillion of assets across private markets, public markets, and for wealth clients. Our entire investment performance relies on the understanding, the ingestion, the analytics, the analysis, and the output of data. And the opportunities of generative AI in our space are absolutely huge.
We think that generative AI has loads of exciting applications across our industry and others, and can also bring huge value to Schroders and to our clients. We can't wait to innovate with it, but we do need to balance that innovation with the need for security, data privacy, and client confidentiality, as well as making sure that we focus our resources on the right places.
As someone who works with natural language processing, one of the things that's got me very excited about generative AI is that we're producing applications which really do allow users to engage in activities and complete tasks that otherwise would have been impossible. Internally, we've deployed an AI assistant, which we call Genie, globally to our 6,000 users. It has both chat functionality and document QA functionality, which is supported by Azure OpenAI's implementation. The chat functionality is used for a wide range of tasks, such as translation, and also for coding tasks associated with the construction of systematic portfolios. Document Q&A allows users to interact with documents that are hundreds of pages long, far too long for them to read exhaustively, and allow them to answer questions that they otherwise might have missed. It uses an in-memory vector-based search to shortlist the sections of the document, which we then summarize using the large language models. We found the Azure OpenAI implementation to be really fast, really useful to have isolated resources between our environments, especially useful for load testing. And additionally, we found APIM to be an essential service during our efforts. It really does come in useful for allowing us to track where costs are incurred, but around the various endpoints that we have in the application.
So our next challenge is going to be scaling up. We've created huge demand within our population for the capabilities that we've delivered, and particularly the ability to use internal documents in a secure way has really, really driven the enthusiasm for the product. But the challenge we've now got is how do we create a more holistic capability? How do we upload large amounts of data and documents that Schroders has into the capability so that we can query it? And vector-based search is really the only option here.
We're looking forward to using the vector database capabilities within Azure Cognitive Search to help us to evolve Genie further and make it more valuable for our users.
When it comes to vector-based search, what we really need is our language developers to actually jump straight in and just rely on the service and have all the scalability concerns taken care of by that service.
There's so much opportunity with this that prioritization has been critical, and finding the use cases that have a lot of value, but that are also unique to our organization is really important for us going forward so that we know where to focus our resource.
Great. Well, thanks to our customer, Schroders. And with that, I'll call Dom back on stage. Thank you so very much.
Thank you, Pablo. That was fantastic. And it's pretty amazing to see how customers are leaning in with this technology faster, I think, than anyone has ever seen in other tech paradigms before. So it's pretty exciting, and we're super happy to be able to help customers with that. And so another area that I want to share is plugins, right? We heard about plugins before. What are we doing in Azure OpenAI to help customers leverage plugins? Some of the problems we wanted to tackle with these models is where these models fall short today, right? They're great with lots and lots of different languages, probably fall short a little bit in some tier 2, tier 3 languages, some Asian languages, African languages, et cetera. OpenAI also has something called a retrieval plugin that talks to multiple vector databases. We wanted to also incorporate that as a first-class thing within Azure OpenAI. Lastly, we wanted to tie Azure OpenAI to information in the web so you can ground it with more relevant, recent information, as that's what's most useful, and build applications on top of all of this, right? And so, happy to introduce Azure OpenAI Service plugins, where this will be interoperable with all the plugins that OpenAI has, but what we're focused on first is to solve some of these key problems by integrating these Azure services or Microsoft services into our plugins to allow for these models to be extended, for you to build applications on these models, extend them out to these various Azure services. All of these are managed, all these sources are managed with Azure AD and managed identities, so your application can only access stuff that it's authorized to. And then additionally, because of some of the newness and the potential and learnings in this space, we want to ensure that we provide administrators with the control to only enable plugins that are approved in your enterprise for your Azure OpenAI resources. So you can then administer what folks can see and what folks can't see. So I'm going to quickly demo this, and hopefully the demo god smile on me this time. At first, you don't succeed, right? OK, so I'm in Azure OpenAI. I have a new section for plugins where I can enable this stuff. I can, as you can see, I have 3 plugins enabled: Bing Search, Translator, and Cognitive Search, what Pablo was just demoing. And so I'm going to pretend here that we've built a Copilot that faces Contoso Manufacturing Corporation. And there's a problem with there's a problem with a part. There's a customer complaint that I'm trying to figure out what the customer's saying and help them resolve it. So in this scenario, a customer email came in Vietnamese, and I don't know if I want to trust the model quality in trying to parse out the customer's concerns. So I want to use Azure Translator, right, which has really high translation accuracy. So I go ahead and send that in, and I want to make sure that it not only translates, but the model then acts on the translation to help summarize what are the client's most key concerns. And so we wait for this to come in. Obviously, this is something that is in preview and that we're working on. And so what we're seeing here is that they're worried that proper due diligence hasn't been done on air quality. They want to make sure that the air quality standards in the documentation may be outdated. And so they want us to just double check, right, if everything is working right. And so actually, if you look at this down here, we see that the translator plugin has been used, and we see the output of the actual translation. So at this point, I'm going to ask it, hey, what are the testing standards? And so when I type in this, the model obviously says, I don't know this information. I should now reach out to Cognitive Search with my index, with my documents, to understand what parts are relevant to extract that information out. And great, it says that these are the testing standards. It provided me with a number of tests. But it says that it's using a ISO standard, and I don't know if our testing standards have been up to date. This could be an old document. So I'm gonna go explore on the web to see what is the latest standard, and do I have that covered in my documentation? So I'd say when was ISO last updated? And at this point, the plugin service reaches out to Bing Search, the Bing Search API, and determines that the plugin was last updated in 2010. And if I go to the source, it sure enough links to the ISO standard, and I can see here that Well, this is going to load pretty slow, so I'm going to give up at that point. But as you can see, we've extended the model's capability to reach out to a number of external systems. It'll help you build more powerful co-pilots and leverage multiple sources of data that's out there. So if I can go back to the slides now. Thanks much. And so during the keynote, we covered configurable content filters. This is another important area of control that we wanted to introduce for our customers. Today, we run content filtering in line with the service. We filter out the prompts and completions to ensure that no harmful content in these following categories are filtered. And so what we've now enabled is the ability to adjust the sensitivity of your content filters. And so you can, by default, medium severity harms are filtered out. You can adjust that now to say, hey, you know what? In the sexual category, I don't want low severity harms as well, so you can filter that out. And I don't want to. There's plenty of great content. It looks like we ran a little long with some demo issues, so I don't want to hold you all up here. The last thing I'd say is that we have provision throughput, which is an offering for production applications that running at really large scale to ensure that they can reserve the capacity they need for their production applications. It's going to be available in very limited form for large-scale applications on our service. Please reach out to your account team if you want to learn more. And that's it. I'll recap with some next steps. We covered a lot of announcements here. Please take a picture of that QR code, visit it, and you'll get updates on when this stuff is available. All of these are coming early June, so please tune in for these updates, and we look forward to seeing what you'll build with it. Thank you very much.